Week 8 lab lecture. So this is lab lecture 8A. Again, this week we're going to continue on with the semester project. This area this week is the lighting description and other miscellaneous energy use or large energy use items in the project building. So the first area that we're going to be looking at, this section has the following areas. We need lighting schedules on a space-by-space basis. We need the number of fixtures. We need to separate by different types of fixture. So some spaces may have 3 or 4 or even 5 different types of lights. We need the type of fixture that it is. So generally they're divided into 3 subcategories. Is the light hanging down from the ceiling so it's free hanging in the space, also known as a pendulum style light? Is it recessed up into the space, or is it a surface mount? In other words, the light is partially hanging in the space but not completely surrounded. So one of the dimensions of the light is mounted to a surface. How many lamps are there per fixture? The type of lamps in the fixture, so fluorescent, incandescent, LED, HID, what are they? The wattage of the lamps in each fixture. Now, depending on the lamp, if they're fluorescent, all fluorescents have ballasts, with the exception of inductive lamps. The type of ballast, if needed. Magnetic ballasts are the oldest form of ballast. Followed by hybrid ballast, which there were only a couple years where those were dealt with. That would have been in the early 1990s, followed by electronic, which is the widest in-use ballast currently, and followed by a ballast factor. In other words, how much is the ballast wattage, how much is it going to add to the overall wattage of the light? It's usually specified as some sort of multiplication factor or an adjustment factor. Most of the time it's greater than 1. Some of the newer electronic ballasts are actually less than 1. They'll actually reduce the wattage of the overall lamp. The next area will be the lighting condition. So we talk about if there's a lighting maintenance program in place. The vast majority of buildings do not have any type of lighting maintenance program in place. In other words, do they routinely clean the fixture? Do they clean the lamp? Do they have the lamps on some sort of relamping schedule? In other words, every so many hours of operation, we're automatically going to change out the lamps. Now, this will become crucial when you finally get your lecture on lighting. That's still to come. There are certain types of lamps that have a depreciation factor over time. In other words, they still use a lot of energy, but their light output drastically drops. Relamping ahead of a complete burnout brings back the efficiency. So actually, it's more cost effective than simply doing what most people do, and that's wait for a lamp to completely go into a burnout. Is there a need for a control adjustment? So are timings on lights appropriate? Are the adjustments, if we're using like an occupancy sensor, are those adjusted right? If it's a more elaborate lighting schedule, are the schedules, do they make sense? Have they been updated to match what the current building usage is? The last maintenance feature are all the different reflective surfaces. Are they kept up, either with cleaning and painting? So light doesn't just get to a work surface directly from the light to the work surface, but it bounces off stuff. It bounces off ceilings, it bounces off walls, it bounces off the floor. Are those surfaces kept up with like the first day that the lamps were put in? Again, doubtful. Now, occasionally people paint things, but occasionally they change the paint color. Trust me, when lighting was originally put in a commercial or industrial building, In most cases, if a lighting engineer was used, they took paint color into consideration when the original lighting was put in. Now, this impacts the amount of foot candles that reaches the work surface. So that's the actual quantity of light reaching the work surface, which is the area where we're conducting whatever the business of the space is. That's the area that's regulated by either code, industry, whatever, is how much light is actually reaching whatever we're trying to accomplish in that particular space. The next area would be lighting control. What types of control? Are they manual? In other words, a simple switch. Are they automatic? In other words, is there some sort of light sensor or motion sensor? Are they digital? In other words, a full-blown DDC control system where they're on complex scheduling or they're using a complex set of sensors and scheduling where we have sensors looking at occupancy, we have sensors looking at natural light coming in and adjusting light. So lighting control can get very complex in large commercial buildings. How do the lighting control impact the lights? So is it by motion? So any type of motion impact the lights on and off? Is it by light level? So is the control changing the lights by dimming? Does natural light impact the level of light or the lighting control in the area? And then current adjustments. Are the lighting controls adjusted correctly? Timing, like on motion sensors, is it appropriate? Scheduling, if it's a complex system, adjustments of thresholds of sensors, all those things have to be looked at. And then finally, we need light levels or foot candles at the work surface. Now, it should be taken at least twice. There should be a daylight reading and there should be a nighttime reading. In other words, we're taking it during the daytime where we can take into consideration natural light, and then again at night to make sure that lighting levels are still appropriate when we don't have access to natural light. Now, this does present a problem. Not all customers are real happy with you coming back to do a number of different measurements. So that's another one of those things that has to be carefully negotiated with the building owner. The lighting level should be taken in a specific pattern in a space. You typically take a look at the space. You try to take a light meter and measure directly under a lamp source or a fixture source. Then you try to take another measurement at a work surface is close to in between a cluster of lamps as you can, or in a dark spot in a room, or what appears to be a dark spot. So you're trying to get a rough idea of what the range of light level hitting the work surface is. Then finally, once those are taken, the light levels are compared to the IESNA. That's the Illuminating Engineering Society in North America standards. They're the professional organization that sets standards on how much light should be hitting or striking a work surface for a particular task. And trust me, they have a book that's probably 8 inches thick, and they have looked at every possible task on the planet. I was shocked at the tasking that they've subdivided it into. Now, they'll give recommendations on proper light level range for a particular task, and again, they write their standards in such a way as they're easily adopted into local code, just like ASHRAE does for the HVAC field. So that's our go-to group for light level. And then finally, we're going to have an area of other energy users. All other major energy using devices, whether they use electricity or whether they use other sources of fuel, propane, wood, natural gas, fuel oil, whatever, those all should be noted. Large items could include industrial equipment, kitchen equipment, special area equipment. Small items, depending on how small, we still include them. So computers, vending machines, small appliances, etc. You try to pick up as many of the pieces of equipment as possible. Occasionally it's easy to miss a piece of equipment that's only used on a rare occasion and it doesn't use a whole lot of energy. Those are easy to use. So you're trying to make sure that you pick off the stuff that's used on a consistent basis, or if it's a rare basis, if it uses a lot of energy. Equipment can be placed in a schedule format or in a paragraph description. It should include the area located, the name and type of equipment, energy data or usage, scheduling or operational hours and time, and the special conditions of the operation, if any. So any information regarding this special piece of equipment should be put in. Now in Lab 8, in this lab you'll fill out all of the lighting and other equipment schedules for the project. Again, you're going to use the space input forms. You're going to look up proper light levels for the from the IENSA and compare with building values. Now I've included as a resource a snippet of the IENSA handbook, where you can look up some lighting levels. Now in this case, it may not have some of the real specifics for this particular building. That's okay. Try to get as close as possible. I realize this building we're doing has some unique areas. Again, try to get as close as possible, but I couldn't post like a 10,000 page manual. You also are going to have the lighting levels that were taken on site were only able to take during the daylight time. They were not able to take them at night. So these are a daylight only light level. Again, this lab is in a form format. Like that should be like, not light. Sort of bizarre. I got used to typing light so much I didn't type like. Like most of the previous labs. You're going to fill out the forms. You're going to save the file with your name in it. You're going to attach it back to the lab. And you'll have one more week under your belt. This ends Week 8's Lab Lecture 8. You now can proceed to Lab 8. Thank you.